Thank you, Pauls. So, good afternoon, everyone. It's really a pleasure to be here in Riga for this event. This movie that we just saw, I thought was excellent. Lev showed me the movie yesterday, one of the organizers here, and said that he was going to be, or that the organizers were going to be playing this movie, and I think it's an outstanding one because it really does a couple of things. It sends a few very, very important messages. First of all, it shows you how important space has really become for society, not only in helping us develop certain products that are used in space, but also on the ground. But the space has actually developed infrastructures that we're using today. We have telephones that we use and communications. We have meteorology. We have precision in the data that we receive today, the information that we receive today that would have been inconceivable 10 years ago. So space already today has paid off. But now the question is, how does it go on from here? And this is where it works. The question is, what are the next steps? Because if you think about it, with every stage that we went through in the space domain, there were innovations, and these innovations were not only relevant for use in space, but many of them were actually relevant for use on Earth. And so the question is, what are the things that are coming our way now? And we saw some of them in the movie just now. It would be impossible within the 18 minutes that I have at my disposal to actually look at each sector: Earth observation, navigation, telecommunications, and so on. So I'm just going to single one out, one that I worked with a great deal and that's also very close to my heart, which is human exploration of space. And so if we ask ourselves the question of what is it that is going to be happening next in the space sector with respect to human spaceflight, then the answer is, or at least the European answer is, the Terra Nove program. The European Space Agency program, which expects to be sending Europeans to the moon by 2030 and targets sending Europeans to Mars by 2040. Now, as far as 2030 is concerned, if I look at a lot of the activities that are going on these days, I think that that's a very realistic objective, and I think that we will see boots on the moon by 2030 or shortly thereafter. As far as 2040 is concerned, well, we'll see. But what's important about all this is what the advancements are that we're expecting. What are some of the things that we can already recognize today that will be happening in the years to come that will also help us make these huge steps from outside of our Earth's orbit, outside our magnetosphere, over to the moon and beyond? And the answer is, well, one thing that's going to be very important is to send scouts out to do a reconnaissance of certain regions on the bodies that we land on the worlds that we land on. So what does that actually mean? Well, it means rovers, which have to be more autonomous than they are today in order to be able to react quickly. We're talking about robotics. We're talking about the interaction between humans and robots to make it some sort of a symbiotic interrelation where the robot and the human are working together towards a certain objective. And I mean, we see this in science fiction movies, but fact of the matter is that as we go further towards these objectives of reaching the moon and most of all reaching Mars, we're going to see this not as science fiction but as science fact. We're going to be working with more sophisticated laboratories because already now we're thinking actually more than thinking, we're working towards returning samples from other worlds back to Earth and to investigate those, to explore those, to study them. Healthcare and well-being, finding new ways of providing that is going to be important. I mean, if you think about it, you know, when we send people out to the International Space Station, imagine an astronaut gets sick there, and appendicitis. I mean, it's not pleasant, but that astronaut can be back on Earth and in the operating theater within a couple, well, I don't want to say a couple of hours, but within a half a day to a day, which is probably all right. If somebody's on the moon, coming back might not be as quick. And if somebody's on Mars, that person might have to wait a year and a half before he or she can come back to Earth. So there has to be some way of providing remote medicine, telemedicine. There has to be a way of diagnosing the ailments that people have when they're far away. I mean, again, if you're on the International Space Station, it's a quick ride home. But if you're on Mars, getting there takes a half a year, getting back takes a half a year, and you've got two choices while you're there to come back, either after 30 days or after a year and a half, because of the proximity of the two planets. So what happens if somebody says, so there, you see the problem that I'm talking about. So telemedicine is a key point. And then there's another point. When you're in Earth orbit and you have a spaceship circling the planet, then you also do have the possibility to replenish in certain intervals. You know, you go up and you bring some food and a couple of drinks. But when you're on your way to Mars, and there's not going to be another supply ship chasing after you, trying to give you what you need. In most cases, the way it's going to work is that whatever you take along on that trip is what you're going to be using to tide you over until you actually get back to Earth. So what that means is that there has to be responsible consumption, there has to be good resource management that also has relevance for us on this planet here. So you see that there is this interplay between what's going on out there and what's going on here. Space is relevant. It's relevant for today's life. And so with all that said, the question is, well, okay, if all this is relevant, if this is what's coming our way, then what kind of people are we looking for? What kind of backgrounds do people have to have in order to advance us in this way? And here I have a slide, and this is a large part of the picture, but it's not the entire picture. So what you see on this slide, let me see. It doesn't really work. So let me see if I can walk over here. What you see on the top here are the various applications, so launcher development, spacecraft payload development, ground stations development, spacecraft ops, and science and scientific data exploitation. And here you see the disciplines that we hire most frequently in the space sector. And so the way to read it is that, let's say if you're an aerospace engineer and scratching your head wondering what it is that you could do with your degree in aerospace engineering, well, you could go into any of these areas where you see the dot. And what I really want to emphasize is that, especially with regard to the disciplines that you see on the left-hand side, that is not the entire story, even within the field of STEM. There are some disciplines, for instance, if you notice, you don't see chemistry there, you don't see biology there, right? Well, biologists and chemists are also hired. But if you ask me, what are the professions that are most frequently hired in the space sector? Those are the ones. And then the others are also hired, but at a in smaller numbers. So that gives you an idea, and it's all STEM. Now, that said, I don't want to be misunderstood on this, because if I look at the situation that we had have at the European Space Agency, I would say that probably 3/4 of the employees that we have at ESA are in some sort of a STEM field, but that means that about 1/4 are not. And so there's also room in space for people who do not have degrees in STEM areas. That's sort of a footnote that I'd like to add. Our focus today, however, is on STEM. So we continue with STEM. And there's a certain way that we think about the system working, right? Because we think about the government putting the framework into place, the strategic plans, that the areas that the government wants to focus on, Earth observation, because of resource management, telecommunications to bridge long distances, whatever the focus of the government might be. And that's also, hopefully, where the money goes. So then you've got space agencies, you've got industry that look at these policies, and they then think about how the projects could actually be designed, how they could be implemented in order to meet the requirements of the government. Still looking at it from a top-down, not looking at it yet from bottom-up, new space type of approach. Then, bottom left-hand, we have universities, and what do? Well, they prepare the engineers, they prepare the scientists for tomorrow, and on what basis? Well, based on the STEM education that they received. The most young students, first-year students or first-semester students who come to study a STEM subject were usually quite interested in STEM subjects when they were in secondary school. And then bottom right-hand, you see that the schools, in fact, play an instrumental role, which is probably no secret, in the sense that they prepare the engineering and science students of the future. So the problem is that we have a problem. The problem is that what we're finding in many countries across Europe is that there are fewer and fewer students who are actually showing an interest in the STEM subjects. So there's a larger, if they want to go to university after school, there's a large interest in the social sciences, psychology, sociology, law. They might be more interested in the humanities, but the STEM subjects are slowly but surely falling by the wayside. So then if that's the problem, it goes on that obviously if that's happening and it's continuing to happen, then somehow the current approaches that are being taken are not serving the purpose of getting young students interested in STEM subjects. So if that's the case, then we have to ask ourselves, what can be done about it if we really aspire to have all these wonderful benefits that space, and by the way, that also other technical, engineering, scientific areas can offer? So what I'm suggesting, my proposition, the proposition, is that this issue cannot be solved in one place alone. This issue cannot be solved in a school expecting the science teacher to motivate all the kids. That's not going to happen because it hasn't been happening. So what should change? What should make it different all of a sudden? So something somewhere along the way has to give. And so I'm going to throw a couple of ideas out there. And the real message is, even if a teacher is very interesting in the way that he or she teaches the subject, there's always room for more. There's always room for something that really motivates kids. And just a little tiny anecdote along those lines. I've got a 17-year-old grandson, and Tristan. And Tristan has been thinking about what to do with the rest of his life. And he's been thinking about different professions. He's been thinking about becoming a business administrator. He's been thinking about becoming a pilot. He was thinking about becoming a doctor for a while. And then about 2.5 months ago, his class had a field trip to the university, Technical University of Darmstadt. And at this university, they came into contact with several teaching assistants and a couple of professors who actually showed them some of the work that they were working on in the field of engineering. Tristan came home with his eyes wide open like this, and he has been talking about nothing but engineering ever since. And if I were a gambling man, I would venture a bet that this is going to continue until he finishes school, and it's going to continue beyond where he actually goes to university. And so the point is that it doesn't take a huge amount of additional effort. The message is that oftentimes a single experience can actually change the trajectory. And so with that in mind, I'm suggesting schools can do field trips, space-related events like stargazing parties, space-related topics in the curriculum. I mean, if you can measure or calculate the circumference of a circle, you can also measure the size of an orbit around the planet because it's the same arithmetic, and so forth. You know, so to pick up, just to assume this subject of science, of space science, and to show these kids that, you know, calculating a circumference of a circle actually can be perfectly relevant in the right context. I mean, how often have you heard a school kid say, oh, you know, we're learning these things like measuring circumferences or whatever, and we're never going to use it? Well, here's a place where you would use it, and there are many other examples like that. Universities can have numerous kinds of activities as well. First of all, academic programs, you know. We saw this, again, University of Darmstadt, interesting case, because when I arrived in Darmstadt some couple of decades ago, they didn't have any sort of a space program, interestingly enough, because they have two space agencies in Darmstadt they have had for a long time, the European Space Agency and EUMETSAT, the meteorological organization. Nevertheless, there was nothing that was offered in the way of space at the university. And rather than to start a whole faculty, a whole department of space, what they did was they had certain courses that were being taught in the field of mechanical engineering, in the field of electrical engineering and the like, and then eventually they consolidated it. A very interesting test case. There are also the aspects of collaboration. Space agencies, the European Space Agency, I mean, we've had, I don't know how many contracts with universities to do studies for us. And so there are many ways that industry can get involved, but the most important thing, or academia can get involved, but the most important thing is that there's also this interplay between academia and space agencies and industry. And the great thing with industry, of course, is that it gives students the possibility for hands-on type of work. It gives them the opportunity to meet with people who actually work in the space field already. And there are various things that industry can do as well. What's important is that from the industrial point of view, it's understood that by allowing interns to come in to work alongside of the professionals in the company, that this is actually an investment that the company is making in its own future workforce. And so from that point of view, it's also really important for agencies, space agencies, and for industry to be involved in this. Finally, of course, there's the role of government. Governments do basically define the framework, they provide the funding, and the more that a government can do in nurturing and promoting the dialogue between the universities, the schools, the industry, and to provide the kind of support that these various institutions require in order to be successful, this is really the key point that governments can contribute. So finally, my last slide, a couple of messages, a few thoughts to bring it to a close. The first is that space exploration is amazing. There's no question about that. But, by the way, it's also useful. And to reap the benefits that space offers, it's really essential that there's a sufficiently large number of qualified engineering and science-educated people in the market, in the job market. But what this means is that there also has to be a sufficiently large number of students who are educated in the STEM field and who feel sufficiently attracted to it so that they actually do make that kind of a career choice. So in order to achieve that, since we recognize that current approaches aren't really increasing STEM numbers, what it means is that in order to achieve this, it's important that initiatives are taken. And it is not enough to think in terms of the other type of institution that should be taking these initiatives. It's a joint effort if the joint benefit is supposed to be reaped. So that's it for me. Thank you very much.
Thank you so much, Frank. Thank you, Frank, so much. Really happy, yeah, you can leave it here. So happy you came. Frank will be back on the stage for our panel discussions to start putting down your questions. Thank you, Frank, again.
Okay, thanks very much.
Thank you. Very big round of applause to Frank.
Thank you.